Greetings, welcome to Self-Assessment Lesson 9, Question 4, Part C. So there might be a trend here. So we saw in Part A there were two solutions. Part B there was one solution. I'm guessing in Part C there are going to be no real solutions. We're going to have to use the quadratic formula to find our complex solutions. So let's see if I'm right about that. So again, as usual, we need to write it in the form of ax squared plus bx plus c is equal to 0 before we go any further. So let's do that. So we've got x squared plus 3x plus 7 minus 2, which is equal to 0. And I'm going to subtract 2 from both sides. Or better, probably could have gone straight there to x squared plus 3x plus 5 is equal to 0. So I'm already suspect that there's going to be no real solutions to this because I see that the vertical intercept or the y-intercept is at 0, 5, which says, yep, pretty likely this thing doesn't cross the x-axis, okay? But let's go ahead and take 30 seconds to try and factor it. Okay, done, didn't factor, so let's go ahead and use the quadratic formula here. So a is equal to 1, b is equal to 3, c is equal to 5. We know x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if you have not yet memorized that, may I advise you to do so. That's an important formula. You're going to see that in many other classes besides this one. Okay, so let's go ahead and load in everybody where they belong here. So that is going to give me back a negative 3 plus or minus the square root of b squared, which is going to be a 9, minus 4 times an a, which was a 1, times a c, which was a 5. All of that divided by 2a, which is 2 times 1, which is just 2. Okay, so now we need to simplify the part that is under the square root. That part actually has a name. This is called the discriminant of the quadratic, the b squared minus 4ac part. And if that value is less than 0, then we know we have a complex conjugate pair of solutions. And as a matter of fact, what we see is that that's what? Negative 3 plus or minus the square root of negative 11 divided by 2. Okay, cool. Well, so we've got the square root of a negative number, which means this is a complex conjugate set of solutions, and we need to come back up here and reference what they asked us to do. They need to give their solutions back as x equals a plus bi and x equals a minus bi. So let's do that. So let's rewrite this as negative 3 plus the square root of 11i all over 2, and then let's go ahead and break that up into negative 3 over 2 plus the square root of 11 over 2i, and negative 3 halves minus, oops, back up here for just a minute, I forgot my plus or minus up there, sorry about that, square root of 11 over 2i. Okay, so those are our two possible solutions. That's our x1 and our x2 if you want to think about it that way. Okay, so we're going to need to take a look at a graph of this. So let's go ahead and get a sketch of the graph here. So we'll get our calculator out. Go into the y equals, clear out the craziness from the last problem, and let's go ahead and type that in as x squared plus 3x plus 5. Don't know any better, so I'm going to try a zoom standard or a zoom in a 6. Just as we suspected, it does not touch the x-axis, therefore we don't have any real answers. But we have got the vertical intercept and the vertex shown as they ask in the problem, so we can go ahead and make ourselves a good sketch of that. So let's come back over here in the box and notice this is supposed to represent our viewing window. So there's my x-axis, there's my y-axis going from negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis, and we see that our graph looks not quite unlike but similar to that. Okay, all right, now we can't label our real solutions in the graph. Notice they said label any real solutions because we don't have real solutions, But they did say use your calculator to check your answers, okay? Well, in the previous two problems, we checked them by doing graphing. Here, we're going to actually have to plug them back up into the equation. In particular, we're going to plug our solutions into this version of the equation and see if it comes back out to be equal to 0. So to do that, I'm going to go ahead and clear out what we've got on the graph here. I'm going to go ahead and store that complex number into x. A little trick that's going to make my life a little bit easier. In other words, I'm going to go negative 3 divided by 2 plus, I can only put one in at a time, the square root of 11 divided by 2. And then hopefully you recall that your I is the second function above your period. So if you go second decimal point, or call it the period, whatever you want, you'll get an I there. And now I'm going to press the stow button. It's kind of kitty corner to the 1 right here. And then I'm going to press X. And what that's going to do is that's going to take that number and it's going to store that value into X for me. Notice it gives me back the decimal approximation, which has been difficult to carry around with me. I would have rounded off and things would not have come out so sweet. But now that I've stored into X, all I have to do is type in x squared plus 3x plus 5, hit an enter, and voila. Okay, not voila, la chunk. Let's do that again. X squared plus 3x plus 5. It's actually a lot harder to use this calculator than a physical one. There we go. Now voila, it is now equal to 0. Okay, so if I go second enter, there's my mistake one right there, and second enter one more time, I can get back to this little ditty that I did and hit the right arrow until I get on top of the plus, change that to a subtraction, hit an enter, and now I've got the other complex solution. So that got stored into X again, and I can go ahead and say, okay, let's do x squared plus 3x plus 5, and let's see if it worked in that one. And sure enough, both of those worked. Both of them came out to be equal to 0. So we have indeed found our complex conjugate pair. It's negative 3 halves plus 11 halves I, and negative 3 halves minus 11 halves I. Okay, hopefully that all made sense. And again, as usual, if you have any questions, please do not be shy about posting them up to the question and answer forum.